Fractions, wee doggy! Here we go. All right, don't let the fractions intimidate you, okay? You guys have already heard me say that if I can get rid of fractions, that's exactly what I'm going to do first, is get rid of them. By the way, I made a mistake when I typed this up. There should be a y in this example. Sorry about that. All right, anyway, in order to graph this, we're going to need to find the x and y intercepts. And you could do this without clearing the fractions, but personally, I'm going to get rid of them. You can do what you want, but I don't like fractions, and I'm going to get rid of them. And the way you get rid of fractions is by multiplying through by the LCD. And the LCD of 5 and 3, and if you want to treat this as a fraction, it's over 1. The LCD of 5, 3, and 1 is 15. And if you're still not sure of how I'm getting that, what you can do is count by 5s, count by 3s, 5, 10, 15, etc. Count by 3s, 3, 6, 9, 12, 15, 18, blah, blah, blah. The first number that's the same in both lists is for, I can't talk. I'm running out of steam, guys. It's 6 o'clock at night on Friday, and I'm still here at Clark. I'm still at work. I'm getting tired. I'm running on fumes. It's 15, okay? That would be the LCD because it's the first number that's the same in both lists. All right. We're going to multiply through by 15, and what I recommend we do is divide first, then multiply, not multiply first, then divide. Can you multiply first? Sure, but why would you want to work with 60 when you can divide by 5 and work with 3? That's much better, right? Smaller numbers are generally going to be better. So divide by the downstairs, multiply by the upstairs. 15 divided by 5 is 3. That 3 that we got from dividing times the 4 on the tippy top is going to be 12. So this first piece all boils down to 12, and that's much prettier to look at least I think, than 4/5. Now we start again with 15. 15 divided by 3 is what? 5 times the 2 on the top makes 10. With this minus in the middle makes, I guess you could treat it as negative 10 if you want. All right, almost there. 15 times negative 1 is negative 15. All right, that's much, 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 much prettier to look at, I think, than this stuff with the nasty fraction in it. Now we can start looking for our x and y intercepts. Let's do that. To find the x-intercept, I'm going to ignore y. So this minus 10y I completely ignore, and what's left is the equation that I need to solve to find my x-intercept. Divide both sides by 12. Bam! Here's my x-intercept. Negative 15 over 12. Can we reduce that any? Yes, we can. We can divide both by 3, right? Divide by 3. And when we divide both by 3, what do we get? That's going to be negative 5 over 4. Now, nothing wrong with this answer, but since we're going to be graphing, it's easier to interpret the decimal of this, the decimal equivalent, than the fraction. And again, the danger is you might treat this as a slope and go down 5 and right 4, or up 5 and left 4, something crazy like that. This is not a slope. This is a point, not a slope. Slope is a rate of change. This is a single point in the coordinate plane. That might sound inconsequential, but it's very, very important to understand that this is not a slope. It's a point. Okay, now specifically, negative 5 over 4 as a decimal is negative 1.25. And if we're doing the x-intercept, what's y? Always. Y is always 0, right? Y is always 0 when we're doing the x-intercept. Looks good. Now let's find our y-intercept. Here we go. To find y, we ignore x. 86 it. Ignore it. It's not there. What's left? Negative 10y equals negative 15. That's what I need to solve to find my y-intercept. Divide both sides by negative 10 to unglue that negative 10 that was multiplying the y. To undo multiplication, we divide. That's the inverse. Division is the inverse of multiplication. And a negative divided by negative is a positive. When you divide a number by 10, it's the same as moving the decimal point one place to the left. So eventually this is going to boil down to 1.5, but I want to keep us in that groove of reducing our fractions, because for other problems, I'm still going to expect you to do that. You might as well continue that trend and still practice it here. So we can divide both of these numbers by 5, ignoring the negatives because that's going to make a positive. 15 divided by 5, 3. 10 divided by 5, 2. What's my fraction reduced? 3 over 2. And then as a decimal, it's 1.5. Now, what does that mean for my point? My point, my y-intercept, is going to occur at 0, comma 1.5. If I'm doing the y-intercept, my x is always 0. Okay, very good. Now, to graph this, I got to decide how I'm going to scale my axes here. Well, I mean, how much space do I need is what I'm trying to decide. So negative 1.25 for x, 1.5 for y. That's not bad. Okay. Let's get it. Let's do it. Let's get this thing graphed. Put this to bed so we can start enjoying our weekend, right? Let's do it. Get some tick marks going on here. Negative 2, negative 4, 1, 2, 3, 4, 2, 4, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, and 4, 2, 4. All right, looks good. Let's do it. Graph this line. How do we do that? With our intercepts, right? That's what it says to do. Graph the line using the intercepts. We don't want to violate the directions. The New Yorker and me will come out if we violate directions in a problem. Don't do that. Follow the directions. Negative 1.25, that's going to be a quarter to the left of negative 1 on x. Since this is our x-intercept, I'm going to be on the x-axis. Here's negative 1. I go slightly to the left. I want to kind of guesstimate where negative 1.25 is. I'm going to say it's right about there. Maybe you think it's more to the left. Maybe you think it's a little bit more to the right. In any case, that's where I'm putting it. Now, 1.5, that's our y-intercept. On the y-axis, I'm going to be halfway between 1 and 2. Place a dot halfway between 1 and 2. There's my y-intercept. I have my two intercepts plotted. Connect them, slap some arrows on the ends, and we are done. I appreciate you guys taking the time to watch these videos to make up for our missed class on Monday. It means a lot to me, and really this material is important for you. This is for your benefit. I look forward to grading your exams and seeing how the results shake out. I think you all are going to do very well, but regardless of the outcome, we'll deal with whatever happens after I get the exams graded. And I hope to have those done for you by Sunday evening, so you can check STI and check your grade if you're interested in that and see how you did on the exam. All right, this is Mr. Miller calling it a day. It's Friday, September 8th. It's a little bit after 6, and I am out of gas. I am spent. Hope you guys got some value out of these videos. Hope you enjoyed them a little bit. Look forward to seeing you guys next week. Enjoy your weekend. If you're watching this video on Monday, enjoy the rest of your evening. See you guys soon. Adios. Ciao.